Good afternoon, everybody. Here are your notes and examples for section 4.2 from our textbook. It's going to be solving trigonometric equations. Remember, solving equations is trying to find the value for the variable that makes the equation true. However, the trick or the new thing for trigonometric equations is going to be that there's going to be an infinite number of solutions that make it true, because if you have a solution point on your circle, let's say that at 30 degrees for a sine equation, if you said the sine of some angle alpha works out to be a 1:2 ratio, you're looking for all the angles that would make this true. So it would be true that alpha could be 30 degrees, because at 30 degrees you're going to have a 1:2 radical 3 special triangle that is going to get you a 1:2 sine ratio. However, it would also be true that you could be in quadrant 2 at 150 degrees. So another solution would be that you could be at 150 degrees, because that also is going to get you a 1:2 negative radical 3, and your sine ratio is also going to be 1:2. So there's a 1:2 sine ratio at 150 degrees. There is a 1:2 sine ratio at 30 degrees. So 150 would be another solution. So both these values for alpha could be plugged back into the original statement to make a true statement, because it would be true to say that the sine of 30 degrees, that's a solution for alpha, does indeed equal 1/2, and the sine at 150 degrees would be a true solution for alpha, because that also equals a sine ratio of 1/2. And there wouldn't be any solutions in quadrant 3 or quadrant 4, because your sine ratios in quadrant 3 and quadrant 4 would be negative 1:2, because your y value would be negative. So you're going to get two different solutions out of two different quadrants. So one of the things you're going to need to be looking for when you're solving trig equations is finding all the locations, all the quadrants where you have these potential solutions for the different trig functions. But also, to add on to that, not only are 30 degrees and 150 degrees solutions for this original equation, the sine of some angle is equal to 1/2, so that was the original equation here. The sine of some angle equals 1/2. So not only do 30 and 150 degrees work, all the coterminal angles are going to work as well. For example, if my solution point was here at 30 degrees, if I added 360, a full rotation to this, and I went 360 degrees all the way back around, well, now you're going to be at an angle of the 30 degrees plus the additional 360 degrees. So you could add 360 degrees to the 30. You're going to be back to the same place on the circle, making that same sine ratio of 1/2. And you could add 360, you could subtract 360, you could add 3 or 4 or 5 rotations of 360. So what we're going to say is that we can add any multiple of 360. So it's going to be true at the coterminal angles as well. So any multiple of 360. And that is going to be our definition for all the solutions that occur at this particular location in quadrant 1. And then it would also be true in quadrant 2. We have this location in quadrant 2 starting at 150, and if we add rotations, we get back to an angle that's going to be in the same location. So the same location as 150 degrees, and any of those angles are going to make true statements. And then we could put that into what they call set builder notation. and put on your set brackets. So you have a solution set for alpha such that alpha is equal to 30 degrees plus any multiple of 360. And you have a solution set for alpha such that alpha could be 150 degrees plus any multiple of 360. So that's kind of the big idea for pretty much all of Chapter 4. It's going to be solving trig equations and looking for that missing angle and finding all the quadrants where that solution will occur, and then also considering all the different coterminal angles that are in that same location. So let's go ahead and look at a few examples. And here's some of the examples from the notes. So it says find all the angles in degrees that satisfy each equation. So the first one is going to be cosine of x equals 1. And if we want to get x by itself, we can take the inverse cosine of both sides. So we used inverse cosine back when we were solving for missing angles, when we were doing right triangle trig. And you can make your ratio of 1 kind of look like a fraction, 1 to 1. And remember, cosine is the ratio of x to r. So this is the x and this is the r. So you need to start thinking about your unit circle and where can you get an x value of 1 and an r value of 1. So if we have a unit circle with radius 1, and we start thinking about the ordered pairs, if our radius is 1, then this would be over 1 up nothing. This would be over nothing up 1. This would be negative 1 on the x, 0 on the y. And this would be 0 on the x, negative 1 on the y. So where can we get an x value of 1 and an r value of 1? It looks like right here. So this is going to be one solution point on the circle, since our x to r ratio is 1 to 1. At 90 degrees, x is 0. At 180, x is negative 1, so that's not going to work. And at 270, x is 0 again. So it looks like, in this case, we just have this one solution point. So for our solution for our angle x, we'll say that x could be 0 degrees plus multiples of 360, since if we rotate a full circle, we will keep getting back to that same solution point. So plus 360, you can go as many times around as you want, as long as you land right here. That would be an angle that is going to give you a cosine ratio of 1. And then you can put this in set builder notation. So put your set brackets on it. So the way you would read this is you have a solution set. This is called a set bracket. So a solution set for variable x such that x is equal to 0 degrees plus any multiple of 360. So that should be an example for the first one. Cosine of some angle equals 1. That angle has to be 0 degrees plus any multiple of 360. And here's the next one. Cosine of some angle equals 0. So x will be the inverse cosine of a 0 to 1 ratio. And remember, the cosine ratio is x to r. So for this, you're going to be looking for x values that are 0 and a radius of 1. So if the radius is 1, this point would be 1, 0. This would be 0, 1. Negative 1, 0. And 0, negative 1. So at what points on the circle will the x be 0 and the r be 1? It looks like right here at 90 degrees would be one location. So x could be 90 degrees plus multiples of 360. And the other place where x could be 0 would be here. So your x is 0 here, and your x is 0 here. So x could be 270 degrees plus multiples of a full rotation. So that would be two different sets of solutions. For some solutions, you can actually simplify this and put the two ideas together. Notice instead of going a full rotation of 360 off of each one, you could just start at the first one at 90 degrees and say that you're going to rotate 180 to get to the next one. And then to get from this one back to this one, you're going to add 180 again. So sometimes there is some symmetry, and you can put them together and just say you're going to go by multiples of a half circle. So if we wanted to put these two together, we could go ahead and say that x is equal to, starting at 90, plus multiples of 180. And just this one statement will basically hit both those different solution points. So you only need that one statement for this one. And here's another example. This one is an example where they don't land on one of the axes, the x or the y axis. So the cosine of some angle needs to be -1/2. So if we start thinking about where cosine can be a -1 to 2 ratio, in order for cosine to be negative, the x would need to be negative, and r would need to be positive. So where can cosine be negative? If we remember, all skiers take chances. This was an acronym that we talked about back in Chapter 1. It kind of tells us where things are positive. So Quadrant 1, this says that all 6 trig functions, all 6 trig ratios are positive. And this one, sine, and its reciprocal cosecant would be positive, so S stands for sine. In Quadrant 3, tangent and its reciprocal cotangent would be positive. And in Quadrant 4, cosine and its reciprocal secant would be the positive ones. So where is cosine going to be positive? It's going to be positive in Quadrant 4, and it's going to be positive in Quadrant 1, where everything is positive. We're looking for where is it going to be negative, so we're going to be looking in Quadrant 2 for a negative cosine ratio, and also Quadrant 3. So let's go ahead and sketch that out. So we'll look in Quadrant 2 for our first solution, and we know we're looking for x equals the inverse cosine of a -1 to 2 ratio. Remember, cosine is x to r, so your x will need to be -1, and your r will need to be 2, which means this will be radical 3, which means this angle here would be 60. So if it's 60 off of 180, then the angle of rotation would be 120. So at 120 degrees, you're going to have a cosine ratio of -1 to 2. So we can say x is going to be 120 degrees plus multiples of 360. And if we look in Quadrant 3, you're also going to have a negative x. This would be 2, which means this would be negative radical 3 on the y. But we're looking for a -1 to 2 cosine ratio. So that's going to be right here. And again, this would be 60 degrees. So 60 degrees beyond the 180. So this is our 180 mark. So it's going to be 80 degrees, 180 degrees, plus another 60 degrees beyond that. So that should be 240 degrees. So our other solution point for angle x would be at 240 degrees plus multiples of 360. And those would be our two solution sets. And let's go ahead and look at the next one. So this one, it's going to be the cosine of some angle is a 0.3 ratio. A 0.3 ratio is not one of our special ratios off of a special triangle, 30, 60, 90, 45, 45, 90. It doesn't make that 1 to 2 or radical 3 to 2 or radical 2 over 2 special ratio. So for these, you're just going to want to use your calculator and it will find the angle for you. So to start, we're going to do the inverse cosine of both sides to get x by itself. So if we're doing inverse cosine, remember this is the ratio. You just want to type this into your calculator and see what it gives you for an angle measure. And just make sure your calculator is in degree mode. Type in inverse cosine of a 0.3 ratio, and your calculator is going to say it's at approximately 72.5 degrees. So we're going to get a solution at every 72.5 degrees plus multiples of 360. So if you rotate back around to a coterminal angle, that will also be a solution. But the other question is, what's the other quadrant where this is going to happen? So notice it was a positive 0.3 ratio. So where's the other place that cosine can be positive? It can be positive in quadrant 4. So the one the calculator gave us was in quadrant 1, 72.5 degrees. So we need to have the same triangle just in quadrant 4. So if this is your 72.5 degree angle right here, a rotation of 72.5, then this will be your 72.5 degree angle in quadrant 4. So what is that rotation starting from 0? So if we start from 0, it's going to be short of the 360 mark by essentially that 72.5 degree angle. So you're going to want to do 360 minus the 72.5 degree number and see what that rotation is in a positive direction starting from 0 going the long way all the way to here. So do 360 minus the 72.5. And if you do that, you should get 287.5 degrees. So 287.5 degrees is the other solution point. So you have this one here at the 72.5, and then you have this one here that rotates all the way to 287.5 degrees. So we can say x is going to be equal to approximately 287.5 degrees multiplied by, or added to, multiples of 360. And that would be our two solution sets. So you have this one and you have this one. So one solution set out of quadrant 1 and the other solution set out of quadrant 4. And let's look at a few more examples. This one is the same set of directions. Find all angles in degrees that satisfy each equation. Now let's go ahead and do this one. So sine of some angle is equal to a -1 ratio. So how do we get x by itself? Take the inverse sine of both sides. So remember, if you're doing inverse trig, inverse sine, then this is our ratio. And we're looking for angle x. So remember your sine ratio is x, or excuse me, that was cosine that we were just doing. Your sine ratio is y to r. And where can sine have a -1 on the y and a +1 on the r? So that's going to happen on one of the axes. So we'll say r is equal to 1. So x would be 1, y would be 0. At this word pair, x would be 0, y would be 1. And x would be -1, y would be 0, and x is 0, y is -1. So where on these 4 points do you have a -1 on the y? And that will be right here. And it's not going to happen at any of the other y values. None of those other y values are -1. This one's kind of close, but it's not -1, it's +1. And the radius can't be negative. So we're only going to have this one solution point at 270 degrees. So x equals 270 degrees plus multiples of 360. And that's going to be your one solution set, since it only occurs in one location. And the next one, sine of some angle equals 1/2. We actually did this one at the very beginning of the video, so we're going to skip this one. If you want to look back at the very beginning, that was basically the one that we did right here. The sine of some angle is equal to 1/2, and we said that we would get these two solution sets. So 30 degrees plus multiples of 360, and 150 degrees plus multiples of 360. So looking at the next examples after that one, we have tangent. So same directions, they want us to find all angles in degrees that satisfy each equation. So we'll do inverse tangent of both sides. That will get x by itself. Inverse tangent of a 1-to-1 ratio. So if the ratio doesn't look like a fraction, go ahead and make it look like a fraction so you can figure out what you're dealing with. So remember, your tangent ratio is y to x. And it's going to be a positive tangent ratio. So where can tangent be positive? According to all skiers take chances. Where can tangent have a positive ratio? That's going to be in quadrant 1 and in quadrant 3. And let's go ahead and make a sketch. So the solution coming out of quadrant 1 says your y is going to be 1 and your x is going to be 1. And that's going to start making a 45, 45, 90 special triangle, so this will be radical 2. So that means one solution is going to be at 45 degrees. So x equals 45 degrees plus multiples of 360. What's the other place that tangent can be positive? That's going to be in quadrant 3. And we're going to need the same angle, the same triangle, so this would be technically a -1, -1, radical 2. But a -1 divided by a -1 is the same thing as a +1, which is what we were looking for. So that's going to be our second solution point. So we had one solution point here. We'll have our other solution point here. This is your 180 mark. And remember, this is a 45, 45, 90, so this is 45 degrees beyond that 180. So it's going to be 180 plus 45 degrees to get to that solution point. And that should get us 225 degrees. So we could say x could be 225 degrees. plus multiples of 360. And that's not a bad answer. You can simplify this a little bit because we do have that symmetry again, where your solution points are half of a circle away from each other. So you could start at 45 degrees. That's your first solution point. And then to keep getting to the next one, you could go 180 to get to this one. And then you could go 180 to get to the next one. And then you could go 180 again to get to the next one. So we could simplify this and say that we're just going to start at 45 degrees and add multiples of 180. And that would be a more simplified way to write it, because you can describe the same thing in one sentence instead of two different sentences. So 45 degrees plus multiples of 180. And let's go ahead and look at the next one. So tangent of some angle equals negative 1.34. Negative 1.34 is not one of our special ratios from a special angle, so we're just going to use a calculator on this one. So we'll say x equals the inverse tangent of a negative 1.34 ratio. And we just want to type this into the calculator. Just make sure you are in degree mode. And when you put that into a calculator, your calculator is going to give you an answer of x is approximately located at an angle of negative 53.3 or so degrees. And your calculator just kind of gives you the angle that's the closest to zero, the fastest way it can get there. Typically in an answer key you would see that as a positive rotation. So if you're going to go back negative 53.3 degrees, what would that be as a positive rotation going this way? So we know this is our 360 mark. So you're basically falling short of 360 by 53.3 degrees. So you could do 360 minus the 53.3 degrees and see what that is as a positive rotation, which should work out to be 306.7 degrees. So going the long way from here all the way around will get us to this solution point, which is at 306.7 degrees. Plus multiples of 360. And then where's the other place where tangent can be negative? So tangent could also be negative in quadrant 2. So you're going to have a second solution point in quadrant 2. It's going to need to be the same right triangle as what we had in quadrant 4. So this angle here, the 53.3 degree angle, will need to be right here. So what is this solution point coming off of 0? Again, this is your 180 mark. So your 53, because this is 53 degrees right here, you're 53.3 degrees short of 180. So you're going to want to do 180 minus 53.3 degrees to see what that is starting at 0. And that should get you 126.7 degrees. So x is approximately 126.7 degrees plus multiples of 360. And again, just like the other tangent problem a minute ago, Tangent usually has that symmetry where the solutions, the solutions are half of a circle away from each other. So you could say we could start at this first solution point and just rotate 180 to get to this one, and then 180 to get to this one. So we could say, to simplify this a little bit, that we're just going to start at the first one, 126.7 degrees, and rotate multiples of 180 to keep getting to the next one. Sine and cosine usually don't have that symmetry. Tangent usually does, because tangent is positive in quadrants 1 and 3. So they're half of a circle away, and it's negative in this quadrant and in this quadrant. So it's half of a circle away. So you usually find that symmetry in the tangent problems. So that's going to be your solution set for this one. And let's look at one more example. This one, they just want the solutions from 0 to 360. And here's our equation. So we start out with a 2 cosine alpha plus 2 equals 3. So you're going to need to get cosine by itself first. So we want to subtract 2 from both sides. So that will leave us with 2 cosine alpha on the left equals a 1 on the right, so 3 minus 2, and then divide both sides by 2. So we'll divide by 2 and divide by 2. Your 2's will cancel, so you're left with cosine alpha equals a 1 to 2 ratio. And to get alpha by itself, we want to do inverse cosine of both sides, so that gets alpha by itself. Equals a 1 to 2 cosine ratio. And let's bring this to another screen because we're starting to run out of room. So we said alpha was going to be the inverse cosine of a 1 to 2 ratio. And where is that going to occur? Where can cosine be positive? So cosine can be positive in quadrant 1. And remember, cosine is x to r. So that will be 1 to 2, which means this is our radical 3. So from here to here, this solution point, that is going to be 60 degrees. So alpha can be 60 degrees plus multiples of 360. And where's the other place that cosine can be positive? Cosine can also be positive in quadrant 4, so you're going to need the same triangle to make the same ratio. So this is going to be 60 degrees here also in quadrant 4. And what is that going to be rotating from 0? You're going to go all the way to here. You're basically going to be 60 degrees short of a full circle 360, so this will be at 300 degrees. So that is your second solution point. So alpha could be 300 degrees plus multiples of 360. But if we go back and look at the directions just wanted solutions from 0 to 360. So basically just the first rotation around the circle. And I'm looking at the work. There's a slight little typo here. We took the inverse cosine of both sides, so this should actually not be an alpha here. This should be inverse cosine, since that's what we were doing. So we were doing inverse cosine of a half. So let's clean up that typo. So we had cosine of an angle equals a ratio of a half. Take the inverse cosine of both sides, you get alpha by itself, and then do the inverse cosine of a half. So we were working with this, and then we took it to the other screen. They just want the solutions from 0 to 360. So first trip around the circle, one solution would be at the 60, and the other one would be at the 300. We don't need to include the multiple rotations since that would be beyond 360. So our solution set won't be an infinite set of solutions, it will just be a finite set of 60 degrees and 300 degrees. And that should be your final answer for that one.